Okay, so there appears to be some confusion about critical values in the hypothesis testing section. And so I just wanted to make a quick little video to highlight those, to talk about them. And so all right, so we're in hypothesis testing. And questions, the critical value question will ask something along the lines of, what is the critical value? I think they would say something along the lines of associated with a, and I'm just going to use a left tail test with, say, an alpha of 0.05. Okay? Now, we'll talk about right tail and two tail tests also, but critical value. All right, so first things first. Critical values are, at their core, z-scores. And then what does z-scores tell you? Well, z-scores tell us that we're working with a standard normal distribution. A standard normal distribution has a mean of 0. Let me make this go away. And a standard deviation of 1. Right? Now, a critical value is just simply the highest or lowest, or the two values, depending on what kind of test you've got. Since we're working with a left tail test here, is going to be the lowest value over here that is going to split that normal distribution into two regions. One region over here is going to be the rejection region, and the other region over here is going to be the fail to reject region, and the alpha level is just going to tell you the size of those two pieces. So this one is going to have a 0.05 or a 5% size, but if that's 5%, then this over here must be 95%. And so all the critical value problem is asking is, what is that number right there? Well, we did this like, I don't know, it felt like 100 times. It was probably closer to maybe 15 times in chapter 5. This is a normal distribution where we know the size of that left tail. And so we would find that critical value, that z-score, by doing an inverse normal, where we're going to say, what's the z-score? What's the critical value? They're calling it a critical value because we're doing hypothesis testing, but it's just a z-score. What's the z-score that has that left tail of 0.05? So then I'm going to go grab my calculator, and excuse me, I forgot to start it before I made the video, so it's going to take a moment to start up. And I'm just going to use that inverse normal command like we've used before. Let's see if I can make this work. Normally that works better. All right, I'm going to pause this. I'll come back when I got the screen set. Okay, so I got the screen set up now. So I am going to find that left tail. So like I've done before, I'm going to go to my distribution menu, and I'm going to use option number 3, inverse normal. Inverse normal, this is a left tail. I just want that 0.05. My mu is 0, my standard is 1. I paste that back in, and I get that the z-score is negative 1.645, or that my critical value for a left tail alpha 0.05 is negative 1.645. Okay. I know what you're thinking. Well, what if the problem, instead of asking for a left tail, asks for a right tail? Well, if you're doing a right tail hypothesis test, so let's say we're doing a right tail hypothesis test. So now this is going to be a right GH, there's an H in there, tail, alpha 0.05. That just simply means switch that picture around, find that value right there so that this piece is our 0.05, but if the right is 0.05, what's that left going to be? Well, that would be 0.95. So then I'm going to go back to my distribution menu. I'm going to go to that inverse normal, and I'm going to say, okay, what's the 0.95 for that? And that means that this would have a z-score, a right tail critical value of 1.645. And if the problem happened to be a two-tail, alpha 0.05, well, it still means a standard normal distribution, but this one's a little trickier because now it's going to have two values, and those values are going to be symmetric. And what I mean by that is like, I don't know what the answers are, but whatever those answers are, if the left one is negative 1.2, then the right one will be positive 1.2. But the total area here and here has to add up to our 0.05. So each of those pieces would be 0.025. Okay. And I'm just going to find the left one because then I don't have to think as much. I'm going to find that left one by just going back to my inverse normal command. 0.025. And I get that this one is a z-score, or a critical value. Negative 196? But if that one's negative 196, then the other one being symmetric is positive 196. So my two-tails would just give me those. Now, of course, as the alpha level changes, the size of those tails changes in either the two-tail, the right tail, or the left tail test, but the logic is always the same. Critical values are just z-scores. Z-scores are found by using a normal distribution and just putting the tail in the right place and getting those areas. So I hope that cleared up any confusion that you might have had.